Let's start with chapter 11, 12, atom. In this chapter, we'll study about various models for the structure of atom and atomic spectra, right? In this chapter, we'll study about various models. We'll study about various models for the structure of atom and atomic spectra. Structure of atom and atomic spectra, right? Just right. Structure of atom and atomic spectra. Correct. Number one, we'll start with Thomson's atomic model. Right, students? Give heading. Thomson's atomic model. The first part is theoretical. Let's know it. Student J.J. Thomson in 1898, right? The full name was J.J. Thomson. In 1898, suggested that atoms are just positively charged and charge of lumps of matter with electrons embedded in them, right? Like resins in the fruit cake, right? What he suggested, right? J.J. Thomson in 1899 suggested atoms are just positively charged are just positively charged lumps of matter with electrons embedded in them right, like resins in the fruit cans. And this model is also called plum pudding model, that is also known as plum pudding model. Why it is known as plum pudding model? Like these students, atom is totally positively charged as for Thomson's atomic model. This is positively, right? This is positively charged matter in which there are few electrons embedded, right? These are the electrons. Just note it. Plum pudding model means, that means it has electrons surrounded by a volume of positively charged, like negatively charged plums embedded in a positively charged pudding. Means pudding is positively charged and plums are the negatively charged, right? There are very few electrons and there is a mass, there are so much of totally is positively charged. In between them there are some negatively charges, right? And the next experiment is on alpha particle scattering and Rutherford's nuclear model of atom. Let's know. Give heading. Alpha particle scattering and Rutherford's nuclear model. Alpha particle scattering and Rutherford's nuclear model. Okay. Student Rutherford was born in New Zealand. Okay. A British physicist proposed alpha particle scattering experiment. Why? To investigate the atomic structure. And this experiment was later on performed by Hans Giger and Ernst Madsen. In their experiment, they directed that, what was the experiment, students? A beam of 5.5 mega electron volt alpha particle, right? In this experiment, what happened? A beam of 5.5 mega electron volt energy of the alpha particle, right? MEV alpha particle emitted from bismuth 83214 at a thin metal foil made of gold of thickness 2.1 into 10 to the power minus 7 meter. Okay. What is the arrangement, students? Like this, let's know the arrangement basics. Just draw it with me. These are the lead bricks, right? These are, just draw. These are the lead bricks, right? Lead bricks, you know, or these are the sources of alpha particle. These are the sources of alpha particles, you know? And from here the beam of alpha particles are leaving, right? Beam of alpha particles are leaving. Okay. There is a thin foil gold experiment. Okay. Thin gold foil, you know. This is thin gold foil, right? This is what? Thin gold foil. Just draw. And this is large, actually, what? And what was the observation? Some alpha particles, small angle scattering, some moved in this direction. Let's change the color to show the alpha particles direction. Some moved in this direction, some got in this direction, right? Some went in this direction, right? Horizontal. Small angle scattering of some, right? This is right. Small angle scattering, right? And this red line that you are seeing, this is the ZNS screen, like zinc sulfide screen. Okay. And there was a detector microscope here. Just draw it, students. Detector microscope. Understood? And some moved in this direction also, correct? Some got deviated. This is backward scattering of very small fraction, 1 in 8,000. If 8,000 particles rays are going, then among them, there is backward scattering, right? Backward scattering of a very small fraction, that is 1 in 8,000 or so, right? और ये जो है, right, this is the angle, large angle scattering of some. These are the large angle scattering of some. You can follow the diagram from the book, right? So finally, what are the important observation out of this alpha particle scattering and Rutherford's model, right? The important observations, right? The important observations from this experiment, the important observations next, right? The important observations. What was students observation, right? For पहला observation ये था कि most of alpha particles most of alpha particles went straight on deflected went straight on deflected. What was it suggested? मतलब इसका मतलब ये था क्यों वो लोग undeviated होके चले गए? That suggested large empty space in the atom. Large empty space in the atom, right? Next, second observation, that only about 0.14%, right? Only about 0.14% of incident alpha particles scatter by more than 1 degree. By more than 1 degree, ठीक है? And third experiment, third observation क्या था? 1 in 8,000, जो हमने लिखे वहां पर 1 in 8,000 deflected by an angle more than 90 degree. Deflected by an angle more than 90 degree. Correct. And the explanation of the above observation led to the birth of Rutherford's planetary model of atom, also called nuclear model. ठीक है? ठीक है, ये सारे ऑब्जर्वेशन फिर किसको लीड किए? रदरफोर्ड्स एटॉमिक मॉडल पे, है कि नहीं? सो राइट द अबव ऑब्जर्वेशंस led to the birth of Rutherford's planetary model, right? Rutherford's planetary model of atom, right? Also called as nuclear model, right? And according to this model, most of the mass, at least हम 1.14%, जैसे हमने यहाँ पर किए थे कि incident alpha particles scattered by 1 degree, most of the mass, at least 99.95% of all the charge of the atom concentrated in a very small region called atomic nucleus, right? Let's know what was the Rutherford's atomic model. This is the positively charged body, right? And this is the atom, correct? ये पूरा atom है और उसका 99.95% न्यूक्लियस है कि नहीं? और इसका जो ऑर्डर है पॉजिटिवली चार्ज इट इज इन द ऑर्डर ऑफ, ये जो इसका जो डायमीटर की बात करें हम, सो दैट इज 10 to the power -15 मीटर। और पूरा एटम की अगर बात करें यहाँ से यहाँ तक, सो इट इज 10 to the -10 मीटर, 10 to the -10 meter. You know 10 to the -15 meter means 1 Fermi, yes or no? And 10 to the -10 meter means 1 Armstrong, yes or no? So from the Rutherford's model, right? Number one observation, most of the mass, this is the theory part we'll complete today. Most of the mass means at least 99.95%, and all of the charge of an atom concentrated in a very small region, concentrated, right? Just a minute. Most of the mass, at least 99.95%, and all of the charge of an atom concentrated, right, in a very small region, concentrated in a very small region is called atomic nucleus, is called atomic nucleus, right? And second observation क्या था? Nucleus is positively charged and its size, right? Nucleus is nucleus is positively charged. Nucleus is positively charged and its size is of the order 10 to the minus 15 meter, right? That is about 1 Fermi जो हमने बताया भी, ठीक है. And the nucleus occupies only about, just right, adds a point. The nucleus occupies only about 10 to the minus 12 of the total volume of the atom. Minus 12 of the total volume. Of the total volume of the atom or less. Great. Next. Last. In an atom, there is maximum empty space. There is maximum empty space and the electrons revolve around the nucleus. Electrons revolve around the nucleus in the same way as the planets revolve around the sun. This one you have studied in atomic structure, I think. Yes or no? As the planets revolve around the sun. Correct. And next class we'll study about alpha particle trajectory, important terms like what is impact parameter, what is fraction of alpha particles, what is distance of closest approach. Then we'll do numericals tomorrow, right? Thomson's atomic model. Then we'll go for electron orbits. Just to go through this theory part today. Tomorrow we'll be having class on the next part, okay?